name is Dan Adeoye, and I would like to talk about Snort. Snort is a lightweight network intrusion detection system which is written with C language. It arrived in 1998 and experienced a constant revise and perfection for more than a decade. It is open source and now it has become a worldwide network intrusion detection and prevention software. Snort can strongly analyze data flow and protocol in real time, and it can be downloaded from the internet and runs on almost all hardware platforms and operating systems. The flow work of Snort is composed of six parts: catching data packages, analyzing code of data, preprocessing the package, passing the rule, detecting the engine, and logging. Besides, the Snort is simple, short, and has good programming style. It is structured and easy to read. The latest version of Snort is 2.8.5.2. And before the setup of Snort, which is a very complex process, which involves detecting the integrity of compiling environment and setup of Apache, MySQL, PHP, ADODB, and ACID components. Now, the Snort official website has provided some simple installation guides for Windows XP, Solaris 10, and Linux. We can quickly and easily build our intrusion detection system according to the guide of installation document, which I'm going to provide right now. You can follow these installation steps if you want to download them on your Windows or your Linux and so on. You can set up the operating system with minimal model, make the unnecessary services disable. You set up the compiling environment using yum command and install the Apache, MySQL, and PHP component. Then you download and install the Snort source code and rule. You modify the profile of Snort and you build the Snort database with MySQL. Then you install the ADODB and the base. You start all the required service and you're good to go. You see, Snort monitors the network in the bypass mode. It catches the suspected data, which attaches the intranet, and also the monitoring results is shown on the basic analysis and security engine, which is the base, which can intuitively analyze the catch data and display it. So the network security was improved by the reference data of Snort. Building the debugging environment of Snort, you can analyze and modify the Snort in your familiar compiling environment. For example, Microsoft VC++ integrated environment. The following is the steps of Snort in VC++, which is installing Cygwin. And Cygwin is a simulation environment of Linux in Windows. You can transplant the application software from Linux to Windows, and you don't have to install the Linux virtual machine. When you set up the Cygwin, please keep the default installation parameters or you will have to change the content of Snort project in VC++. When you install the Cygwin, you should check the setup the Bison related package option, which is included in the devil option. If you don't do this, there will be an error. And if you can't find the command file in the compiling process, you should that's the error it's going to bring out if you don't do this. It's going to bring out can't find the command file in the compiling process. And while downloading the Snort source code, after downloading and unzipping the Snort source code, you will compile it in VC++. Please modify the profile of Snort before running the Snort. This will make the Snort adapt to Windows for more information. Now, analyzing Snort code. The Snort main implements the initialization and monitoring of Snort. The rule tree is the important data structure in Snort. It is helpful to grasp the rule matching of Snort. And Snort is a popular open source intrusion detection and prevention system, which is we can call that IDS slash IPS, that analyzes network traffic in real time for suspicious activity. Snort uses a rules based language to define the criteria for detecting various types of attacks. These rules are typically written in a language specific to Snort. Understanding and analyzing Snort rules involves examining the keywords, protocol, source and destination addresses and ports, content matches, and any additional options. Rules can be highly customized to detect specific patterns indicative of malicious activities. Snows provide flexibility in rule creation, allowing analysts to define rules for various types of attacks, such as buffer overflows, SQL injection, malware traffic, and more. Additionally, these notes can be configured to log events, generate alerts, and even block traffic based on rule matches. Regularly updating and maintaining SNOT rules is crucial to keeping up with emerging threats and ensuring effective network security.